her away, Ian.
Yeah, take it away, Ernie. It's going to be a bumpy ride.
But the muggles, can't they see us?
Muggles?
They don't see nothing, do they?
No, but if you jab them with a fork, they feel it. Right on top of us!
OMG, Ron, you'll never believe this. I was riding the night bus last night and we crashed between two buses. It was crazy. Like the magic stopped working and we couldn't fit.
Ah! No magic?
Who could have done this?
Now we are cursed to be muggles.
Did somebody say muggles?
What you need is an engineer.
What's an engineer?
They're the smartest of all the muggles, Ron. Everyone knows that.
Whoa.
We noticed you were having some troubles with tolerances in the night bus.
What are tolerances?
Tolerance is the total amount that a dimension is allowed to vary. It is defined as the upper limit minus the lower limit of the dimension. Why is it important to define tolerances? In real life, dimensions are not exact and can vary from their specified values. Tolerances affect the cost of manufacturing. Tolerances that specify a smaller range of deviation from the dimension require more precise manufacturing methods, generally increasing the cost. Because of this, fractional measurements that are represented as decimal dimensions should conveniently be rounded to the second decimal place. For example, 3/8 of an inch should be rounded to 0.38 instead of being written as 0.375.
In reality, no dimensions will be exact, and tolerances define just how inexact a dimension can be. Variation can come from several sources. For example, imprecise manufacturing methods and inaccurate measurements can result in parts that do not match the desired dimensions. While manufacturing, imprecise machinery, worn tools, miscalibrated measurement devices, and operator error are all potential sources of variation. Depending on what materials are being used, environmental effects such as temperature and humidity can also affect the variation of dimensions. This is why it is important to define tolerances.
When Ollivander created each of your wands, he had an upper and lower limit for each wand. For instance, Hermione, your wand has a length of 10.75 inches and a diameter of 0.25 inches. The number of decimal places matter. The more precise dimensions in his plans, the more expensive it is to manufacture the wand. In most cases, fractional dimensions with 3 decimal places should be rounded off to 2. His tolerance for your wand, Hermione, was plus or minus 5/100th of an inch.
You can also determine tolerances through limits.
Oh, like when you're drinking butterbeer and you don't want it to go past your limits because you may or may not have a low tolerance?
No, Ron. Limits are the minimum and maximum allowable dimensional values. For instance, if Slytherin casts a spell on the quaffle so that the diameter can't be less than 15.9 inches, but the diameter of the scoring hoop is 16.1 inches, so the diameter of the quaffle has to be between 15.9 and 16.1 inches, making these the upper and lower limits.
Tolerances are especially important when designing parts that fit together. Sometimes a part can be undersized, but it cannot be oversized. Asymmetrical tolerances are a way to report dimensions like this.
For example, the basilisk has to crawl through a tunnel that is 36 inches wide. The widest the basilisk can be is 36 inches, so the tolerance would be reported as 36 inches plus 0.001 of an inch and minus 0.05 of an inch. This is just one example of why we would use asymmetrical tolerances.
But what if the thing I am designing is very complex? Do I need to add tolerances to every dimension?
No, a more efficient way of defining tolerances is by defining general tolerances. This is usually a general note in the title block that applies to all dimensions not covered by tolerances listed on individual dimensions, like this.
Oh wow, thanks guys. Now we can survive a world without magic.
You're welcome, guys.
See you on the flip side.
Goodbye, everyone.
Goodbye, Harry.
Goodbye, Hermione.
Bye-bye.
Goodbye, Ron.
Goodbye, Ron.
Bye.